Hello, in this video we'll talk about the converse, inverse and contrapositive of A implies B, and we'll also talk about some algorithms. So the converse of A implies B is B implies A. We saw the example before. If you don't do your homework, you'll flunk. If you don't do your homework, you won't pass the exam. So the converse would be you pass the exam if you don't do your homework. So my question to you, are these two statements, is A implies B and its converse equivalent? Obviously it's not. So you could check that by doing the truth table for both of them. So the same with the inverse. What would be the inverse of A implies B? So the inverse of A implies B is not A implies not B. So you could see the same example. If you do your homework, you pass the exam. So would that mean the same thing? If I say, if you don't pass the exam, then you don't do the homework. So again, you could do the truth table and see if A implies B and not A implies not B are equivalent. The contrapositive of A implies B is not B implies not A. So again, try the same example and see if these two implications are equivalent or not. So next thing we're gonna do is talk about some algorithms. A set of instructions that can be mechanically executed in a finite amount of time in order to solve a problem. It's called algorithm. Algorithms are usually represented by some pseudocode. Pseudocode is the state in between the verbal form of algorithm and the computer program, like either Java or C or C++. The pseudocode should be easy and to understand even if you have no idea of programming. So like this one, it's very easy to understand. If sugar required, add sugar, else don't add sugar, and if. So this is if-else statement, and most of Java language or C will be written similar to this, except we do some semicolon sometimes at the end of the statement. Let's see this example here. So the question is to rewrite the following statement form with simplified conditional expression where the function add n returns true if n is odd. So here is what we have. We have this pseudocode, but maybe we could rewrite it better. And that's why we are learning this logic and doing this truth table to make our programming or our pseudocode, our algorithm, more efficient and clear and easy to understand. So for example, if not value 1 less than value 2, or add n, or not add value 1 less than value 2, and add number. So if this condition is true, then do statement 1, else do statement 2, and if. So what I'm going to focus on this condition in here. So let's see. If I let A be, A will be what? Value 1 less than value 2. And let's call B, this function, add number. So if I want to translate this condition of this if statement right here, let's take it. So not, what we have is, it says if basically A or B, not, because this not is for the whole thing, A or B, or not A. So again, this is A, but we have not A, and B. So this is the statement that we have there inside the condition. So how can we simplify this condition here? So what I'm going to do is I'm going to do the truth table for this condition in here. So first we negate not A, we negate A, and then we negate B. Do AND connective between A naught and B naught, A naught and B, and then the last two columns AND between them. And then we stop and think, what is the simplest form? What input give us this output? False, false, true, true. A is true, true, false, false. B is true, false, true, false. So what I see is basically if I take A, negate it, I will get here. So not A is false, false, true, true. So basically this statement can be simplified as just not A. So the whole thing, if we want to rewrite it, our condition would be if not A, if not value 1 less than value 2. So as you see, the add function calling it is not even needed. So you say if not A and then statement 1 and statement 2, because all of this is simplified as not value 1 and value 2. So we can write a better condition for our algorithm if we understand the logic better and by using this truth table.